Alright, today I want to talk about going from factored form to standard form, and one of the ways that we do this is using what's called FOIL. That is the acronym that stands for first, outer, inner, last. You might also know this by double distribution, and this is for when we're multiplying two binomials together. So we have something like a plus b times c plus d, and we're trying to multiply those two binomials together. That's the most common sort of factored form where we're trying to go into standard form that you can get. So I'm going to do an example of using FOIL on two binomial polynomials that would be in factored form, and then I'm going to go one step further, and I'm going to take a trinomial and multiply that trinomial by a binomial. So a 3-term polynomial times a 2-term polynomial, for you guys to see more of an example of what that would look like. First, let's talk about FOIL. In the two binomials, each binomial has a first term and a second term. So first and second terms. And then if you're looking at this thing as one whole piece, there's outside terms, in this case a and d, and then inside terms b and c. So that's kind of how we're referring to these things. So in FOIL, using FOIL, you first start out by multiplying the first two terms together. So the first term in the first binomial by the first term in the second binomial. Then you move on to the outer piece, which is the outside two terms of both polynomials, or both binomials. So in this case, it's going to be a times d. And we're multiplying at these steps. So it's a times c, and then we're going to do a times d, and then we're moving into the I, which stands for inner or inside two pieces, and those inside two terms are going to be b and c. So we're going to multiply b and c together, and then when we get to the L in FOIL, that stands for the last, or the last two terms of each binomial, and so you're going to multiply b times d. This is also called double distribution because I'm distributing a to c and d, and then I'm also doing distribution of b to c and d. So I'm doing 2 rounds of distribution, or double distribution. I'm going to do an example of this, and then, like I said, we're going to run through an example of multiplying 3 binomials together to give you a feel for what that might look like when you're trying to go from a factored form to a standard form. So let's first move this off to the side. We could keep that up there. That looks like it gives me plenty of room. And we're going to do something like x plus 3 times x minus 4. Should we start that simple? Let's not start that simple. Let's put a number in front of that x. Let's say 2x minus 5. That should be good. So the first thing we want to do, ironically, is multiply the first two pieces together, which I'm going to do in red. So we're going to do 2x times x. Well, x times 2x. I like to think of going from left to right. So x times 2x is 2x's squared. Remember that when you're multiplying variables, you're adding the exponents together, but multiplying their coefficients together. So there's like a 1 here we don't write. So I do 1 times 2, which gives me this 2, and then x times x, which gives me x squared. Moving on to the outer two pieces. Oh, I just got my color coding wrong from up above. Well, we'll live with it. The outer two pieces now is going to be x times negative 5. And keep in mind, there's still that 1 in front of x. So 1 times negative 5 is negative 5. And then x times the 1, the placeholder of the x, keeps the x on the back of that negative 5. So x times negative 5 is negative 5x. Now we're going to move to the inside two pieces, which are the 3 and the 2x. So 3 times 2x is a positive 6x. 3 times 2, and then the x hangs on. And then finally, the lasts, which are going to be in purple here. The last two pieces of each binomial are 3 and negative 5, and 3 times negative 5 is negative 15. And so there we have it. We've completed FOIL. However, no matter when, I shouldn't say when, but no matter what, at the end of completing FOIL, you always want to double check that you can combine like terms. In this case, I have two x terms that can be put together. They're like, they have the same variable, so we can add them together. And so my final answer becomes 2x squared, and then negative 5x plus 6x gives me a positive 1x, or positive x, minus 15. And now that is our final answer after using FOIL. I'm going to do one more sort of complicated example before we head to the 3 binomials, just so you could see what it looked like where we can't possibly reduce this any further because all our variables won't match in the end. I say that, but now I hope I come up with a good example. So we're going to do 3x squared minus 2 times 5x plus 1. That should be plenty. So we're going to still follow the same thing. We're going to start with the firsts. So 3x squared times 5x. 3 times 5 is 15. X squared times x. X cubed is our result. Then I can move on to the outside two pieces, the O in FOIL. So 3x squared times 1 is just itself. Anything times 1 is itself, so I just get 3x squared back. Next is the I, or inside two pieces, because now I got to do negative 2 with each piece. So negative 2 times 5x, negative 2 times 5 is negative 10, and the x stays. And then the last piece, the L of FOIL, for last two pieces, is negative 2 times 1. Negative 2 times 1 is negative 2. And now, double checking, sure enough, nothing reduces. All the variables are different. All the terms have different variables on them, ranging from the constant term up to 3, a degree 3 variable. So that is our final answer, and we cannot reduce that. So sometimes you'll be able to reduce it. Actually, more often than not, you'll be able to reduce it. Especially in a problem in a math class, they love having you do extra reducing. So always make sure that you can reduce at the very end. Now, our last example is going to be multiplying 3 binomials together. So we're going to use FOIL to multiply the first 2 binomials together, and then we're going to just use a whole lot of distribution to multiply the trinomial that we get by the binomial, the last binomial that we're going to have. So let's start that out, and we're going to have it be 2x plus 3 times x minus 4 times x plus 2. That should be good. So the first thing we want to do is we want to take the first 2 binomials together. So we're going to put some rainbow brackets around those, and we're going to use FOIL with just those 2 binomials. So we start with the F in FOIL, which stands for firsts. So I'm going to do 2x times x, which gives me 2x squared. Then I move on to the O, which stands for outside two pieces. And now this is the outside two pieces of just the first two binomials. You're not going way over here to get your outside two pieces. You're staying inside those first two binomials, inside the rainbow brackets that I put down. So we're going to do 2x times negative 4, which is negative 8x. Then we move on to the I for insides. So the inside two pieces are going to be 3 times x, which is a positive 3x. And then the last 3 times negative 4, which is a negative 12. And now all of this is one thing that we've multiplied together, so we're going to put it in some big brackets. And that x plus 2 on the very back end hangs out because we haven't used it yet. And now, just like before, we're at a place where we've done a bunch of multiplication and we're done with that round of multiplication. So double check that you can simplify things, because sure enough, we can simplify these two terms in the middle, the negative 8x and the positive 3x. So I get my 2x squared. Negative 8x plus 3x is a negative 5x's. If I owe you $8 but give you 3 at some point, I still owe you $5. And then the negative 12 hangs on because we haven't done anything with it. And the x plus 2 binomial hangs out on the very end at the back. Now, here comes a whole lot of distribution. And there's two ways to think about this distribution. You could either multiply each term in the trinomial by each term. Ooh, that curve is not very good. Let's try that again. By each term in the second polynomial. So in this case, 2x squared times x and then times 2. And then we would do negative 5x times x and then times the 2. And then we would have to do negative 12 times x and then times the 2. We could think of the distribution that way, where I take each of the terms in the first polynomial and multiply it by each of the terms in the second polynomial. Or, the way I like to do it, I like to multiply the shorter polynomial by the longer polynomial. So what I like to do is I like to take x and multiply it by 2x squared, then multiply it by the negative 5x, then the negative 12. And then I come through and I multiply the 2 by the 2x squared, and the negative 5x, and the negative 12. Either way, what you need to happen is that you need to multiply each term in a polynomial by every term in the other polynomial. So 2x squared needs to be multiplied by each term in the other polynomial, in this case x plus 2. And then negative 5x needs to be multiplied by every term in the other polynomial. So that every term gets multiplied, every term in one polynomial gets multiplied by every term in the other polynomial. And it doesn't matter which way you think of it. I do love to draw the little arches to make sure that I've paired everything up. That's what keeps me organized when I'm writing this. And I've been doing math for a long time. It's still something I like to do, to just double check that I've paired each term up with every term in the other polynomial. So let's start with doing the x times every term in the front polynomial, that trinomial. So x times 2x squared is 2, oh, but I'm writing in blue, we gotta switch back to the red. X times 2x squared is 2x cubed. So I did that first long arch. Then I'm going to do x times negative 5x, which is negative 5x squared. And then x times negative 12, which is a negative 12x. And so I did every term in the first polynomial by x. And now I'm going to do every term in the first polynomial by that positive 2. And I'm going to do it in blue now. So I'm going to do 2x squared times 2. Ooh, that curve is just not very smooth. So 2x squared times 2 is 4x's squared. And to save myself some time, I'm going to write that 4x squared underneath that other x squared term. I'm going to organize my answer in columns of like terms so that it makes it easier for me to combine like terms later. I'm not hunting all over a big long line of a polynomial to make sure that I've combined the like terms correctly. I'm going to organize them in columns so that it's just more organized for myself. So now I'm going to do negative 5x times the positive 2. 2 times the negative times the negative 5x. Either way you want to think about it. And 2 times negative 5 is negative 10, and it's going to have an x. So it's going to go right underneath that negative 12x, negative 10x's. And now the very last piece of multiplication that I got to do is the 2 with the negative 12, or the negative 12 with the 2. And that's going to be a constant term because both of those don't have a variable. So that's going to start me a new column off to the left. Negative 12 times 2 is a negative 24. I need a new column because that constant term doesn't match my degree 3 or my degree 2 or my degree 1 columns. And now to get my final answer, I can combine like terms vertically because I organized everything up into those columns. So the 2x cubed has nothing to be put with, so it stays 2x cubed. Negative 5x squared and positive 4x squared work out to be a negative 1x squared, or negative x squared. Negative 12x and negative 10 are put together to be negative 22x. And then the negative 24 has nothing to be put with, and so it stays negative 24. And now this is my polynomial in standard form, where I'll be able to find the degree, the constant term, and the leading coefficient, and any other information I need. So I went from a completely factored form all the way down here, let's zoom out a little bit, to the standard form, and that's what we were looking to do today, is go from the factored form to the standard form. I hope this helps you guys out. Leave me any questions you have in the comments. I'd be happy to make a more specific video if you're having trouble. Thanks.